In the previous videos, you guys saw how to solve problems based on symmetric, skew-symmetric and transpose of matrices, correct? Now, the last topic what you will be learning is what is an inverse of a matrix and what are invertible matrices. Okay, so this is what we are going to learn. And of course, you have to find the inverse and all. So first, let's try to understand what is an inverse of a matrix. Okay, so the topic what you are going to learn today is inverse. Inverse of a matrix, correct? Now, guys, you know the meaning of inverse. That is, whenever you take an inverse and the quantity in the sense something like a number or whatever it is. When you take that inverse and the number, that should give you identity. Whether you add, you multiply, correct? Like you have additive identity, so you have additive inverse. You have multiplicative identity, multiplicative inverse. So we are going to understand what is inverse of a matrix. Okay, now inverse of a matrix is, suppose if you multiply the matrix with its inverse, that should give you the identity element or the identity matrix. In the sense, suppose if you take A as the matrix, I multiply A with some matrix, say X, and when you multiply, that should give you I, the identity matrix of the same order. So that X is what we call as the inverse of matrix A. So when you represent, we represent it as X is nothing but A inverse. This is what we call as the inverse of a matrix. Okay, now let me just repeat it one more time. Inverse of a matrix is that matrix, when you multiply with the given matrix, that should give you the identity matrix. Okay, now couple of prerequisites to understand inverse of a matrix. Very first thing, when you talk about identity matrix, it is a square matrix, correct? That means whenever we look at any sort of inverse of a matrix or something, we generally talk about square matrix. Fair enough? So generally speaking, the inverse of a matrix is a square matrix. This is the first thing. Okay. Now the second parameter. So first one, let me just write it down. So the first one what you can talk about is being a square matrix. Okay. The second one. So second one is, see, you have learnt about scalar matrices, correct? So scalar matrices, when you look into that, see, there is a particular parameter called as determinant, which you are going to learn in the next lesson. Now, to calculate the inverse of any matrix, what the very important part is that it has to be a non-scalar matrix. Okay, in the sense, the determinant should not be 0. So what we can write here is that it is a non-scalar matrix. This is also quite an important property. Okay, why it is important, you guys will understand this in a much better way in the next chapter. But it has to be non-scalar. If you remember this much for this chapter, it's good enough. Okay, now having these two prerequisites, if a matrix satisfies these two conditions, then the inverse can exist. Okay, the inverse can exist. That's why in many of the questions you will see, find the inverse if it exists. Okay, now this is basically what we mean by inverse of a matrix. Okay, now once you understand that there is an inverse, there are certain rules, properties and laws and theorems related to inverse, correct? Now we'll discuss one or two laws, what is there for inverse of a matrix. See, the first theorem what we have, theorem, or you can say statement, something like this. Okay, so the first theorem, theorem 1, we can call it. Now what this theorem states is, suppose if you have a square matrix and if the inverse exists, okay, it's a very big if. That means what we have, you have a square matrix. Okay, you have a square matrix, and if the inverse exists, then it is unique. In the sense, one square matrix cannot have two inverses. Fair enough? So what we can say here, that for one square matrix, there is only one inverse. There is only one inverse. It is unique. Okay, now this is the first theorem what we are going to understand. Now guys, it's more of logical way of understanding. It's like image and remember the domain and range we used to do, the element and the image. It's like 1-to-1. So matrix inverse is also like a 1-to-1 relationship, where for one matrix you are going to have one inverse. Clear? So this is the first part. Anyway, you don't have the complete proof of this one, but it's more of a logical thing. It's like when you're going to have one element in the domain, one element in the range, and the one element of the domain has one image in the range. Only one, unique. So likewise, a matrix will have one inverse. Clear? This is the first one. Now let's look at the second one. In the second theorem, what you have is that suppose if you have A, B whole inverse, then this is equal to B inverse into A inverse. Fair enough? This is what we have to prove. Now, there is a very simple proof. We'll look into the proof. See, AB whole inverse is equal to B inverse into A inverse, correct? So now what we'll do, we know that A into A inverse is I, correct? Or A inverse into A is also equal to I. So we'll use that logic here. So what we'll do, you have AB into AB whole inverse is equal to I. Correct? Now what you do, you multiply both the sides by A inverse. That means we are doing A inverse into A into B into AB whole inverse is equal to A inverse into I. Now see here what I'll do, I'll combine these two, just the bracket. Remember, matrix multiplication is associative, isn't it? So A inverse into A, that is I. So I into B into AB whole inverse is equal to A inverse. A inverse into I is A inverse itself. Now I into B is what? B itself. Now what you do, you multiply both the sides by B inverse. That means B inverse into, guys, I into B is B itself. So B inverse into B into AB whole inverse is equal to B inverse into A inverse. Again, grouping it. So you can take B inverse into B together. When you take B inverse into B together, this is going to give you I into AB whole inverse is equal to B inverse into A inverse. Now, what is I into anything? I into anything is the same. So, what do you get finally? So, we'll get AB whole inverse is equal to B inverse into A inverse. This is what we were trying to prove, correct? So, remember, AB whole inverse is B inverse into A inverse. Now, there are a lot of problems which involves this theorem. In the sense, they'll give you matrix A, they'll give you matrix B. Prove that AB whole inverse is B inverse into A inverse, which you have to do the entire not this derivation, as in problem you have to do it. Okay. So, this is what you mean by inverse of a matrix. Now, in the next video, we will understand how to do this. That is, we will look into the elementary transformation. Okay, like what happens when you change the row, column and everything. So, we'll look into the elementary transformation in the next video.